Now we consider the basic theory of feedback oscillator. So here see the block diagram. Here we have in the first block, we have amplifier with gain A. What is gain? That is nothing but the ratio of output voltage V0 divided by input voltage Vi. So this ratio V0 upon Vi is called as the gain of the amplifier. Here part of the output energy or part of the output voltage V0 is taken back and supplied to the input of the amplifier. And amount of feedback energy or feedback voltage given back to the input is decided by this feedback network. So the feedback network will control the energy feedback to the input of the amplifier. So feedback voltage Vf is equal to beta times V0. So beta is always less than 1. Then it will become a fraction. So fraction of the output energy is given back to the input of the amplifier. Therefore, this circuit is called as feedback network, which will control how much feedback voltage is given to the input of the amplifier. Now from this diagram, firstly we define the gain of the amplifier here. We define the gain of the amplifier here by using this relation. Output voltage V0 is equal to A times Vi. Or we can write A is equal to V0 upon Vi. That is the basic definition of the gain of the amplifier. Or we write V0 is equal to A times, gain times the input voltage. This is the case when there is no feedback. If this feedback network is absent, then we write V0 is equal to A times Vi. Now, if there is a feedback in the circuit, or if we connect a feedback network and part of the output energy given back to the input of the amplifier and the amount of voltage given back to the input is adjusted with the help of feedback network, then we write what is the net input voltage Vi. So Vi must be equal to Vs plus Vf. So Vs represents the total feedback voltage in presence of feedback. So that is obviously using Kirchhoff's law. Input voltage Vi can be represented as Vs plus Vf. Or we write Vi is equal to Vs plus beta V0 because feedback voltage is nothing but beta times V0. Here beta is called as the feedback factor and this is always less than 1 because we have to give fraction of the output energy back to the input, fraction. So beta is always fraction, less than 1. So we write Vi is equal to Vs plus beta V0 using 1 and 2. What do we write? V0 is equal to, now substitute here value of Vi. What do we get? V0 is equal to A into Vi. That is Vs plus beta V0. That is we put equation 2 in equation 1. So we get V0 is equal to A times Vs plus beta V0 or V0 is equal to A Vs plus A beta V0 or we write V0 is equal to 1 minus A beta. So bring this term on the left hand side and take V0 common. So we get V0 into 1 minus A beta and that is equal to A Vs. Or we write now V0 upon Vs here. V0 upon Vs. That is equal to A upon 1 minus A beta. So this also represents the gain, output upon the input when the feedback is present. And therefore this gain is called as gain with feedback and denoted with AF. F represents feedback. A represents gain. So AF represents the gain of the amplifier in presence of feedback. So this is the theory of feedback oscillator. So in feedback oscillator, we have to adjust the factor beta and that will decide whether it will work as oscillator or not, or it will produce electrical oscillations or not. that depends upon the value of feedback beta. So two things we have to consider. One, that is the amplitude of the feedback energy, that is voltage or current. And secondly, we have to see the phase difference. If it is in phase, then there is a positive feedback. Let us see what will happen when we consider the positive feedbacks. So depending upon the value of beta. So see, if I take value of beta negative feedback is there, then beta is negative. Then what will happen? A upon 1 plus A beta. This negative and this negative becomes plus. So what do we get? A upon 1 plus A beta. So in this case, the feedback gain of the amplifier decreases. And therefore, this feedback is called as negative feedback. Now, second case, if we take beta positive, then what will happen? A upon 1 minus A beta is greater than AF. So here, the overall gain of the amplifier increases. Therefore, this type of feedback is called as positive feedback. Now, one more case is there. Suppose A beta is equal to 1. What will happen? A beta is equal to 1 means we adjust beta such that this product A beta is equal to 1. Then what will happen? 1 minus 1 is equal to 0. And A upon 0 is infinity. So what will happen? The gain of the amplifier with feedback becomes infinite. Now again we come to the basic definition of gain. Gain is equal to output upon input. And suppose gain becomes infinity. What is the meaning? V0 upon Vi. So Vi becomes 0. Means the amplifier produces the output signal even though there is no input signal. So such a circuit works as an oscillator. And this condition, A beta is equal to 1, is called as the Barkhausen criterion for sustained oscillations. So any amplifier circuit having feedback works as an oscillator when this condition A beta is equal to 1 is satisfied. So in designing of the oscillator circuit, you have to take care that this product A beta becomes 1. And when that happens, at that time, the amplifier circuit or this circuit start producing AC signal at the output, even though there is no input. And that circuit is called as oscillator. So this is the theory related with the oscillator. So oscillator requires amplifier as well as feedback network. And by using feedback network, you have to adjust the factor A beta is equal to 1. So when this happens, then we get AC voltage at the output without applying the input signal. And then the circuit works as an oscillator. Now, what are the requirements of oscillator? Now, from the previous theory, we see that in case of oscillators, we require a tank circuit. We require a transistor amplifier and a feedback network because we see that by using this tank circuit, we produce electrical oscillations of damped type. We are getting here the oscillations whose amplitude is exponentially decreasing and finally it becomes 0. So we have to produce sustained, means continuous oscillations. So what we have to do? We have to supply the energy to this tank circuit so that the amplitude of these damped oscillations will be maintained. So the first requirement is we require a tank circuit which produces electrical oscillations whose frequency is given by F is equal to 1 upon 2 pi root LC as we have seen. But these are the damped oscillations. The amplitude of oscillation decreases and finally it becomes 0. So we have to do some arrangement so that the amplitude will not decrease. It will remain constant. So the oscillations produced by tank circuit are very weak. So the amplitude of these weak oscillations is increased by using an amplifier. So here we get the increased amplitude. And then we have to do what we have to do. We have to supply fraction of the energy of this amplifier back to the tank circuit, so that again the capacitor gets charged to its initial value. And this feedback circuit will provide the energy for charging of the capacitor in proper phase. In oscillators, we see that there must be a positive feedback. We have to make this factor A beta is equal to 1. And that is the work of, or that is the function of this feedback circuit. So feedback circuit adjusts the amplitude given back to the tank circuit, as well as it adjusts the phase, so that there exists a positive feedback. So remember, in oscillators, we must have a positive feedback, first condition. Secondly, we have to satisfy the Barkhausen criterion. Remember this word, Barkhausen criterion. What is that? A beta is equal to 1. Remember, A beta is equal to 1. So A beta is equal to 1. This condition is known as Barkhausen criterion. And when this condition is satisfied, the circuit start working as an oscillator. So the basic requirements for oscillator are: we require a transistor amplifier, we require a tank circuit, and we require a feedback circuit or phase shifting network. And with proper designing of these three, we can make an electronic circuit which produces electrical oscillations of desired frequency. And the frequency of these oscillations is given by formula 1 upon 2 pi root LC. So by selecting the proper values of L and C, we can produce electrical oscillations of required frequency.
If you like this video, don't forget to subscribe, comment and share this video with your friends. Thank you for watching.